Alrighty, hello everybody. Yep, recording. What's going on, everyone? Today I believe is day 23, if I'm not mistaken. Yeah, day 23. Today I'm just gonna do solve a LeetCode problem on stream because I just got like 1,000 followers on TikTok, so I've been trying to go live in the night and just code there and just talk to people. So I'll just do a quick video here and then go on a different platform and finish up over there. But this week I'm gonna plan on doing different videos. I'm thinking of changing. Well, I'm gonna keep on doing these coding everyday videos, of course, but I'm gonna change it up and do I gotta do Twitch as well, and I gotta I think I'm doing like different types of videos on YouTube. Like there's this video I watched, I was like, damn, literally an easy, and it's like advice for lost computer science students, 250,000 views. Want to do something like that, 7-minute video, and the video is just literally like, I'm dead serious, it's just a guy on Minecraft, like just running and like just gameplay of Minecraft and him talking over it. Easy, just go on YouTube, find Minecraft gameplay and just, I don't know, talk over it. And I gotta do the LinkedIn Doom post and all that type of stuff. So there's so much to do in a little bit of time. So I got like almost a month to do everything. So yeah, I gotta grind harder. But yeah, I think today I already did there's stuff on my own, but I haven't solved the LeetCode problem today. So we're still on stacks. I'm still want to do stacks because I'm not very proficient with it, but I understand stacks now. It's last in, first out. So yeah, I'm starting to understand it, but implementing it in code is where I'm struggling with. So let me share my screen. I've been talking too much. We're gonna do this problem, even though I don't like this problem. I actually don't even like, I'm being dead serious, I don't even understand it. So what I'm gonna do is I'm gonna what is it called? What was I gonna do? I was gonna, well, we're right here, so here it is. So I gotta go. Okay, I'm trying to understand this shit, man. So push an element, push element X into the stack, pop, remove the element, top, implement minstack class, minstack. Okay, the minstack initializes the stack object, so that's the class. Void push init value. So yeah, this is push. This pushes the element val into the stack. So what do I do? Thing is like, what do I do here? And get min top pop this initialize the stack object. Okay. Example. So minstack dot push to minstack dot push 0, min stack dot push 3 negative 3, min stack get min. What do you mean get min? Get min retrieves the minimum element in the stack. The minimum? So negative 2, 0, negative 3. Pop and then top. I guess top gets the top element, which is 0. Give me returns negative 2. Get min. I'm not understanding this one though. Retrieve the minimum element in the stack. So min stack. Push negative 2. Push 0, push negative 3. Get min. Explanation. Min stack is new min stack. Okay, so does this mean I gotta make... So I am a bit confused. What I understand right now is that there are different functions in the class that I have to build. For example, push, pop, top, and get min. Right. So what I am thinking is I have to create something like stack is equal to this, then push, top, etc. everything using this stack variable that holds a list. So yes, you're right. You do need to create a class. So push, pop, and you're also around something. So self.stack. So that I knew it was gonna be here. So it has to be self.stack, and that equals this. So right here, what's gonna happen is, if I want to push something, we're gonna get the self.stack append val. I didn't even read it, so don't worry. I didn't look at the answer. Look, don't tell me the answer. The code, I would like to do it on my own. Just give clues and hints. This is what I have so far. So I don't like how I just did that, so I'm just gonna go like this, copy. What is this? Your mistake will be interesting as that. I feel like because also here's some closer methods to help you guys. In your push method, you also want to push self.min underscore stack, the new value if it's a new min. The min? What the fuck is a min? What does getting the minimum mean? Sorry, I don't know if I'm stupid. The smallest value within a set of numbers, or lowest one. Oh, minimum maximum, you fucking idiot. So get the min. So that's why I was getting this. So in the example, when it's getting min, the lowest value is -3. Getting min is okay. I see. Okay. Removes the element on top of the stack. So if it's okay. So you're removing the top on the set, but you're tracking the minimum value. You also need to remove the top of the min tracking stack. Think of both stacks always being the same length. Think of both stacks always being the same length. Just return the last element of your stack. You already know how to do this. Okay, top is easy. So if I do return self dot stack -1, pop is like what? Which one do? Self dot pop, self dot stack, self dot stack dot pop. Doesn't this remove the last element of the stack? Or does it remove the first one? I forgot. Does pop in Python remove the first or last element of a list? Removes and returns the last element. This says, see, that's why I knew. Removes it on top of the stack. So get the minimum. So for to find the lowest, so for what does top do? Return 0. Oh. I think I get it. I finally understood it. It just clicked in my head. So what it's doing is that whenever you want to do something to get the min stack, so there's different functions here. So if you want to push, we're pushing this, we're pushing this, we're pushing this. Now the list is -2, 0, -3. If we want to get the minimum, min stack dot get min, we're getting return 3. Now we want to pop from here. When we pop, the -3 is gone. So now if we do min stack top, we're returning the top, so it'll get return, I guess, the top element of the stack. So it's not -2, it's 0. Okay. Top, and now get minimum. So get minimum, so for num in so let's just say value is equal to negative inf. How does that work? Oh my god, I always forget this. Negative inf something in Python. Infinity. Oh my god. How to do infinity or negative in Python. It's inf, but I just don't know how to. Yeah, this float. That's what I need to do. Or yeah, the most straightforward. Can I do negative? I've seen that before. I guess float this. Don't worry, guys. I do see the negative is not here. I think the negative has to be inside. Yeah, it has to be inside. I gotta remember that's how it works. Just float that. So for num in float in self stack if num what if I use 0? What if I do 0? Negative 2 1. Okay, I guess negative 2 3. Yeah. For num in nums, if I do value is equal to 0, I don't like how this looks right here. If num is less than, no, yeah, less than value, if num is less than value, value is equal, well, value is equal to num. So if I go here and print if I here and print value, boom. So yeah, 0 does work. What if I do float negative inf? Yeah, because negative infinity. I think this would work. Oh, it works if it's if it's infinity. Stupid ass. Yeah, I was like, damn, how does that work with infinity? So it is infinity if num is less than value is less than value. Holy moly, value. We're gonna set value equal to num, and then we return value. Okay. So I see how this is no, negative 3. I want to see what will happen. Holy shit, no way. Bro, if this works, I'm gonna be so lit. It worked, no way. W's, 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 man. Holy moly. But, I ain't gonna lie. My shit is ass. Yeah, man, hold up. So something that I would like to do, since solving this, I get it now. That was easy as fudge. Fudge, man. So let's go here and get my code, copy. What about if I do this? If I run it, will it work with their system? Yes. If I submit it, it's accepted, but let's look at the solution.
Hey everyone.
Oh my god, my ears almost imploded, bro.
Welcome back, and let's write some more neat code.
Dude, my ears almost blew out my head. Holy shit. Give me a second, guys. Okay. Give me a second, guys. I have just 30 seconds. Okay. Okay, let's watch this video. Holy shit, I gotta lower down my volume because it's insane loud.
Today let's solve min stack. So this is a pretty good design problem, and the description is pretty simple. So our job is to design a stack class that supports 4 operations. Obviously, we want to push onto the stack, we want to be able to pop from the stack, and we want to be able to get the top value on the stack. And last but not least, the 4th one, this is the part that's going to be tricky. We want to be able to retrieve the minimum element in constant time. So we want to be able to do all 4 of...
I think that's what was wrong, is this. You know why? This has to go through each number in that list. It probably like did a test case where like the list was long as hell and it took so long that I was like, damn. Thing is that how would you get that in like what is it? What is the what the fuck? Okay, but can I use that though in a... like 1 stack, 2 stacks. What the fuck you mean 2 stacks? Okay, let's just okay. No, I didn't know they have this one.
These operations in constant time. Now, if you are familiar with a stack data structure, you know that by default, a stack will be able to support adding a value, popping a value, and getting the top value, all 3 of those in O of 1 time. Now, I'm not going to go into the details of how to actually implement a stack. You can implement it with a linked list, or you can do it with an array. In this problem, we're basically just going to use the built-in data structure that is pretty much implemented as a stack. But the main part of this problem is being able to do this last operation, getting the minimum value from the stack in O of 1 time.
Yeah, mine is
right?
not.
Because by default, a stack doesn't support this operation. Now, a stack, let's say we're implementing it with an array. So let's say this is our stack. And let's say we do a few operations. Let's just look at this example, right? We push a negative 2. We push it, let's say, to the bottom of the stack. We push another value, a 0. We push another value, negative 3. And now, so we did 3 push operations. Now we want to do a get min. So how exactly are we going to be able to get the minimum here? Well, a naive way would be just look at every single value, negative 3, 0, negative 2. So we can look through the entire stack. That's going to be O of n time to get the minimum. So at least we have a baseline. At least we know how to do it in O of n time. That's not too bad, but how can we do better? How can we actually get it to be O of 1? And if you want to try to figure it out yourself, I recommend taking a look at this hint that LeetCode actually provides. They say consider each value in the stack having a corresponding minimum value. Think about that for a second. So let's go back to the basics when we were adding 3 values. So when we first added a value, we added a negative 2. So what's the minimum at this point in our stack? When we only had 1 value, the minimum at that point was negative 2, right? When we added another value, we added a 0. What was the minimum at this point? When we added the 0, did this replace our current minimum negative 2? No, it did not. So in other words, we can leave our minimum as it is. But that's not always going to work. Having a single value maintaining the minimum isn't always going to work because, for example, let's say we added another negative 2. Okay, our minimum stays the exact same, negative 2, right? Now, what if we pop this negative 2? Okay, we pop that negative 2. Now, how do we know what's the new minimum? Is the minimum going to stay negative 2 or is it going to be 0? Well, of course, we know it's going to stay as negative 2, but how can we do that? So a good workaround is for each position, write down what's the minimum at this point. So when we pop, then we know, okay, this is going to be the new minimum. So let's say at this point, the minimum stays negative 2. And we added a third value. Remember, we added a negative 3. So now what's the new minimum? We can compute it in O of 1 time by just comparing this new value we added and comparing the current minimum. Obviously, negative 3 is smaller. So at this point in our stack, the minimum value is negative 3. If we were to pop this negative 3, then the new minimum would...
How the hell would I known that? And the thing is like, how would you even implement, oh, we're on this index, so this index for now on, after you've pushed that number into the stack, it will be the min is negative 2, like
be a negative 2, right? This would be the top of our stack. This would be the minimum so far. So what you might be noticing is on this right hand side, I'm actually defining another stack, right? We have 2 stacks. One stack is telling us the values that we've added so far in the order that we added them. The other stack is telling us what's the minimum value that we have added so far in each position of the stack. So if we add a value, we'll be inserting into both stacks. If we pop a value, we'll be popping from both stacks. When we get the top value of our stack, right, because remember that's an operation, the top value, we're going to be looking at the first stack. We're just going to say, okay, this is the most recently added value in the stack. When we do,
we're doing a double stack. What? How would you even have known that?
The get min operation, we're going to look at the top of our minimum stack, get that in O of 1 time, right? We just have to get one value, so we can do it in O of 1 time. Don't have to pop anything. We just have to...
I'm actually so curious how this is going to happen.
Take a look at our second stack. So that is the main idea. It's a little tricky to actually come up with this, but once you do, it's very simple. So
my guess is you have another... Yeah, you just make another stack here. Self dot stack min stack, and then right. I think that's how it works.
Now let's actually jump into the code. Okay, so now let's get into the coding portion. So we know that we have to support 4 operations, and in our constructor, the first thing we're going to do is, since we know we're going to have 2 stacks, let's define those stacks first of all. And like I said, I'm going to be implementing this with an array, or at least an array list. If you are using Java, this is not just an ordinary array. We can append, pop from it. It's basically Python's implementation of a regular stack. We're going to have a second array, which is going to be the min stack.
What the hell did I say, bro? Called it. If you wanted to 2 stacks, then you would just have to call the min stack another array right here, and then when you back where he was saying something about like that right there, he was saying we have 2 stacks, and if we want to get the min in a faster big O complexity, you would have to do, you check the index you're already in. So obviously that's gonna have to happen right here. Sorry, to get min. So how the fuck? I don't know how to implement that.
And initially they're going to be empty. So the simple thing to do is push, right? That's the minimum value.
Okay.
Or at least the value at the top of our min stack, and take the minimum of those 2 and then append that value to the min stack. So let's update our value first of all. Let's set it equal to the minimum of itself and the minimum of the top of our min stack. So let's say self.min stack at -1. At least that's how you do it in Python. But we know that this min stack actually could be non-empty, so we're gonna only do this if our self.min stack is non-empty.
Bro makes an if statement in the same line. Is crazy.
Otherwise, let's just take the minimum of val and val. So this might be a little complicated. I probably could have just done an if-else statement, but in Python, I feel like this is a little bit cleaner. So we're just taking the minimum of value and the top of our stack if the stack is non-empty. If it is empty, we're just taking the minimum of val and val, because if the stack is empty, then of course we're just going to take the min stack and append the value to it. Right, so when we append this value, it should be the minimum of the input value and the minimum of the top of the min stack. So that's all for our push function. Now let's do the pop function. We don't have to return anything. All we have to do is pop from our stack, but since we have 2 stacks, we're gonna have to pop from both of these stacks. So popping from the first stack and popping from the minimum stack. So that definitely takes care of everything for us. It feels like cheating since we're pretty much using the built-in functions. And to get the top value of the stack, we are going to take from...
Just do this. Just do that for both.
From the top of the first stack. Always going to be called when get min is going to be returning from the top of the min stack, right? Because we want the minimum value. That's always going to be on the top of the min stack. And this function as well is only going to be, of course, take the minimum of the...
There's no way in hell I would have known that. That's crazy. That's crazy. The 2 stack is pretty cool. The 1 stack right here, that looks terrible. What would it look like in Go? Ugly. Swift. Java. C++. Damn. Horrible way to solve it, but I don't know if that would pass an interview. This is pretty cool though. Well, I guess that's one LeetCode problem down. Now I'm gonna just start doing some stuff on my own. I got some little TikTok to do and stuff, so if you want to mess with me on TikTok, let me know. It's on my bio. But I appreciate you guys for watching and learning with me. That was I don't know, that was a shitty way to solve the problem, but it's okay. Let's see what the next problem on here would be. If I go here, we are in Boep Place. Let me see. Bro, what's happening? Let me go back to Nico 150. Okay, yeah. Evaluate reverse polish notation. You're given an array of strings, tokens that reverse polish and return the. Here, I guess I'll show you guys. Whoa, wrong thing. Screen plus me, man. My bad. You're given an array, strings, tokens that represent a valid arithmetic expression and reverse polish. Run the integer. Maybe integer results of operations plus minus. Assume the division between integers, so input 1, 2 plus 3 times 4 minus 1 plus 2 times 3 minus 4. What the hell? How the hell do you do that? What the hell? 1 plus 2, so 1, 2, plus. So operands may be integers. The operands include this, and that. Okay, you're given an array of tokens that represent a valid or a reverse polish notation. Okay, give me another problem to solve. I might do this one later on my own, but let me just see it real quick. Damn, 2 stacks. Maybe that is a good problem to try with my own since doing that. But anyways, appreciate you guys for watching. That was day 23, I believe. Yeah. So yeah, tomorrow's video. Oh, I have work tomorrow, so I don't know if it'll be short, but yeah. Thank you guys for watching this video. Hopefully on Thursday I can make a long video. I keep saying this, but just the time just be conflicting. But yeah, thank you guys for watching. See you guys tomorrow.